Welcome to another one of the Tech Geeks videos. This is on a how-to, and this is setting up a WireGuard site-to-site VPN. So you can use SiteMagic to do a lot of those. Now there are a few key things with SiteMagic. The owner of the device has to be identical across all the devices you're connecting, and if you do try and move one of them or the owner or change the owner of one of them, then it will break the VPN until they're all back again in the same ownership. I also have an issue that I actually have another firewall in front of my devices, so as a result I have a limitation over what ports can be open, and quite a few ports we found tend to need to be open just to make SiteMagic work really simply and easily. So essentially SiteMagic uses WireGuard to create the VPNs, and I'm a great believer if you know how to do it manually, then if you do decide to use SiteMagic, you'll also know how to do it, how it works in the background. So in this quick video, I just want to show you how to set up a site-to-site. So what I've got is I've got a UCG-Max at one end, and I've got a EFG, an Enterprise Fortress Gateway, at the other. It could be another UCG-Max. It could be a UDM Pro or a UDM SE. The key is that the one end must have a public IP address of some form or be accessible via a public IP address. You could use dynamic DNS to give it a fully qualified domain name, an FQDN if you wanted to, or in this instance I've got a public IP address to connect it. Once that's done, then very simply this is how we're going to set this up. I've only got a public IP address at one end, so I can't actually use this site-to-site VPN option really easily, because I would have really liked to have been able to put in a remote IP address here, maybe a 0.0.0.0, which you can do with some other vendors, and I've not managed to make that work in this fashion, i.e. the one end can be at any IP address. Maybe it's on a 4G, which our connection is. So I figured that the best way I can do this is actually doing a WireGuard VPN. So essentially I'm going to create a VPN server here, and then on my UCG I'm going to make my UCG a client, and I'll show you how this all actually fits together and works. So in our Fortress Gateway I've created the core here for you already, but this is what it will actually look like for you as you go through. So I've chosen WireGuard, I've given it a name, these were automatically created, and then you want to set the public interface. Now as I said, mine's behind a firewall, and so what the simplicity of using WireGuard is that it's going to create a config file for us to download, but because my device is actually behind another firewall, I don't have a public IP address as such mapped to the EFG's web interface. So I'm going to use here an alternate address, which is my actual public IP address, that's then natted through to this device, and that will help me in the config file. You then want to choose an IP range down here. So this will be available to you if no clients have been created, and this IP range wants to be something completely different really to what you might have as defined as networks already in place. So do choose an IP range that's not going to conflict with the other subnets that you have on the LAN interface of your main device. Once you've done this, you're going to choose Add Client, and you can set up whatever you want in here. So you can give it a name, and at this point it's actually going to, you can choose manual, and we'll talk about that a little bit more in a moment. You can choose manual in here. I use auto to download to have all the settings, but essentially they're already here. So I can download the file that I need. You only get this opportunity to download it once, and then you have to recreate the user. Which isn't too much of a problem. It's pretty simple to just download and use the file, which I'll show you in a minute. It's going to create a new interface IP address for each new device that you add. So I've got one UCG-Max connected at the moment. If I add another one, which I could do here, so I could do this as my UCG, so I could do this test site 2 UCG-Max. I like to keep a track of what devices I've got at the other end. It's going to give me another IP address. If I want my remote networks to also be available, you will need to do some static routes from what I've found to be able to, or policy-based routes to get this to work, to have the tunnel come back the other way. You can tick that and then enter the routes or the IP networks I'm going to find at the other end, but we'll just leave that like that at the moment. So if we want to now choose download to actually download and save the file. Oops, now I've clicked the screen away. All right, but you got the idea of what we needed to do. So I've downloaded the file, and then we would have actually chosen add in here. So let me just do, so you can see the test site 2, UCG-Max. I would have downloaded the file and chosen add. And I would have got a second one in here created, and you can see these IP addresses are going up in the synchronization. Now, just a quick word here for those people who may be observant. By standard, the port that it'll use in here is 1024. I'm restricted to only a certain number of ports that were open, so I'm actually using 1194, which is OpenVPN's port, but it doesn't really matter what you set that to, as long as you set that to something that works for you in your environment, or if this is literally on the public interface, there's no actual other traffic being blocked and no other firewall in front, then you can probably leave that on its default port of 1024. So once you're happy with all of this, if you've got an option here to set the DNS, if you want to put in 2 DNS servers, or it'll use Google, then this is all ready to go. So at this point in time, my server is functioning and ready. So now we want to turn our attention, since we've downloaded the file, to our other end. So what we're going to be choosing this, if we go to VPN, we're actually going to be choosing this as a VPN client. And this is actually really cool because we have 2 options in this. We're going to use a policy-based route, and we have a choice to make this a split tunnel or a full tunnel, or a tunnel all, depending on your terminology. What does that mean? If we have a split tunnel, it means only packets that are destined for the networks I define will go up the VPN tunnel. The rest will go out to the internet as the normal way, and I'll show you how we do that in a moment. Or you can do a tunnel all, which we'll have running as part of this setup, which means that all traffic will be funneled from this UCG-Max through the EFG, which means I can enforce my intrusion prevention or my deep packet SSL inspection, my application control directly onto that unit. So here we want to now basically upload the file that we downloaded before, and maybe I can just choose this spinel to EFG if I want to name it. So let me upload the file. So I'm just going to choose the file that I need and actually load this to the device. Everything in here comes in how I need it to be and ready set up. And then once I'm ready, I can hit apply changes. When I come back to my VPN view, I can actually see what it's doing, as in connecting, and hopefully in a moment we'll actually see this VPN create. So this is what I call a one-way VPN, or a client-server VPN, which means it has to be connected from this end, the UCG end. The packet has to be sent or started from this end to activate the VPN. I do find sometimes this just takes a couple of times to start through to be connected. We can also come back here and it shows us as an active client. You can actually go into clients here and it will actually show you as an active item in the list as well. So this is now connected, it's gone green, it's gone through all of the phases. Let me show you a little bit. There are some IP ranges at the other end of this device. And let's just access my Windows machine. So this is my Windows computer. This computer is connected to one of the LAN ports on the UCG. If you want to just have a look and see the config on the interface card, you can see this is my default gateway, this is my current IP address, and if I do a ping to Google, we can see a fairly long latency time. This is on a 4G connection. Now at the other end of the VPN tunnel, is a router, and we'll just pop that in here. Okay, so my VPN tunnel is up and functioning because we could see that, but I can't actually ping down the tunnel at the moment. That's because although we have created this as a client server, this is a little bit different than you downloading the file and running WireGuard directly on a computer, which would have been able to see that other end. What it's actually waiting for is it's waiting for a static route or a policy route. So it does show you in here, it does remind you that to make this work, we need to send or tell it what to find at the other end of the tunnel. So what we can actually do is go to routing, and we can create this policy-based route. So I like to name this what IP range, if you like, I can see at the other end. So I'm going to base this on EFG LAN. So I'm actually going to remind myself where this is. So what this is saying is just a name at the moment. We're going to convert it to something in a moment. We have a choice here of doing all traffic or specific traffic. So specific traffic means that we can just send traffic up here for a specific IP range or a specific IP address. So maybe we're going to just do this as 10.0.1.1 to 10.0.0.1.254 and select the interface. Now we can actually choose the VPN, because we created it, to go up. Where do we want the source? Source I want to be anything that's on the LAN side. All right, and now we can actually add this entry. All right, so it's not, oh, it's because what I haven't done is click the add button. All right, there we go. So I've now created this, so let's just flick back to over here and see if we can see anything that's actually happening. What I'd like to do is like to know whether my route is actually working. So I'm going to do tracert, and I'm going to 10.0.1.1. And I want to actually see whether it's trying to send it down the tunnel. So we can see it's actually going to 192.168.119.1. So now this is really interesting, and this happens for some people, and depends again on how your network is set up. So you won't have to do necessarily all of the bits that I'm doing here. I actually have the LAN side of my device is .21. So what I'm trying to work out now is what is allowed and what isn't down my tunnel. So I can ping the LAN interface of my EFG in the data center, but I can't ping the router that is at the other end there. And sometimes I've seen this is sometimes we still need a policy route at the other end to remind us of where it is. Sometimes you might need a static NAT in place or a source NAT in place to make this work as well. So I am going to cover these little bits for you, but the key that we can see here in our trace that we had here is if it's going to the LAN interface, it is tracing out the right way. It's actually tracing part of the way to this IP address, which we know is at the other end of the VPN. If I was to ping 8.8.8.8, actually, sorry, if I was to trace to 8.8.8.8, we should see this go out to the WAN interface. There we go. It's going out on my 4G connection. So we've actually done a split tunnel. I'm going to actually switch this very slightly now to actually do it as a full tunnel. The same process might be if you just want to only have the split data. But what I can do in this rule is just change this, and we can actually change this to be all traffic. And if I just want all traffic now to be from my source here, and this is going to maybe say all traffic to EFG. So now I can send all of that traffic out to the EFG directly. So if I was actually just to skip back here and do a trace to my 8.8.8.8, I would now expect it to try and go out to the VPN tunnel, and we can see it's gone that first hop along the way of working. I also just want to see, maybe because I've done this now, I might be able to ping that router, but I can't. So I know what I'm going to need to fix up. And like I said, not everybody will need to do these steps, but I will show you in the next sequence what I need to do. But hopefully that's quickly shown you that we can create a split tunnel or a full tunnel in this setup. And then we'll work on shortly actually making this all lined up so that we can actually route traffic all across this, and we'll be able to show you on the ping and the trace how we actually make that happen. So I hope you don't mind me just doing a little bit of a recap again at this point. We've talked about a few concepts here and getting it working. So I just want to do a quick summary just to remind you where we're at. All right, so we've created a server at the EFG end, the master end. This has to have a static IP address. We've used WireGuard. We've created a client. You can have multiple clients in here. They each get a unique IP address, and you could have downloaded the config from there. At the other end, the remote end, this is on a 4G connection, so we don't have a static IP address. We have set this up as a VPN client, and we have imported the config file to actually make this work. So at this moment in time, we then chose routing, and we did a policy-based route that would pass all the traffic to the EFG. So if again we just remind ourselves where we're at on this side, we've got a ping happening over here, so we can see we can go to the internet. But if we do a trace over here to 8.8.8.8, we'll see it goes to the device and then out its default gateway. Which is fine, and that means that all traffic is going. And for many people, that might be all you want to do. You just want to be able to connect this device up and forcing all the traffic to go through your device. In my instance, I actually want to be able to see local subnets. So over at this side here, let me just ping, say, 10.0.1.21. That's the LAN interface of our EFG. And as you can see, it pings. But I've also got another device on the LAN network on .10, and that doesn't ping, which is very interesting. Now, for some of you, you may find at this point in time it does actually work for you. It will depend on how that local area network has been set up. In my instance, the switch that's connected there won't allow traffic to route unless it comes from an IP that's in its range, i.e. it has to come from 10.0.1 an IP address. And on my UCG over here, if I have a look at networks, I've actually got this in a 10.0.5.0, and that's what's going to be seen over the VPN, because we don't actually do NAT when we travel over a VPN. We might in some instances to get around some problems, but that's maybe for another video. But for generally, you will have another, this will be seen at the other end. So my router isn't happy with it, and as a result, it's not allowing that traffic to travel. So I'm just going to basically set a ping going on here, and I'm just going to show you the next step if that's you. What we need to do is create a source NAT rule, an SNAT rule, that essentially rewrites all the traffic that exits the LAN or destined on the LAN and sets it to the IP address of the LAN. It'll all make sense hopefully to you in a moment, but I'm going to go to routing. This is on the master end, the one where we have the VPN server set up, and I'm going to go to NAT, and I'm going to choose a source NAT when I create my entry. So I'm going to choose source NAT, and so I'm going to say translate all LAN traffic. So I'm going to choose anything that travels out of the LAN. So if we think of our VPN, we've traveled from the remote end across a different IP address, a 192 range, and then we want to get to the LAN side. So we're going to actually exit out of the LAN port. And what I'm going to do is I'm going to set this as the IP address of the LAN port itself. So now I've set that up, you can see I've got my rule in place here. So let's actually just go back on this side. Now, this won't necessarily immediately change, because actually the packets are going to be seen still coming from that one original location of my remote end. So I probably want to just break my ping and restart it. I might need to wait a couple of seconds. It seems to take about 1.5 minutes for the rule changes that we add in Ubiquiti to make a change. We also need our session to be broken so that the source of our packets can change to that new IP. So we'll keep giving it a go, and in a moment this should have changed. I was just going to ping the local area network again of the card, and then I'll probably try one of the other IPs on there which now works, and this probably should allow us to try that .10. That's still not working, and we'll try another IP on the network, and I can now see another IP. So that .10 in the worst case will take about 10 minutes for ARP to clear and reset itself, but we're now actually able to ping IP addresses we weren't before. We couldn't get to that 10.0.1.1 IP address, we couldn't get to any of the others. So in a few moments that will reset itself. This is more of a networking thing more than actually related to an issue with Ubiquiti, because those packets are still being seen as from the same MAC and therefore the same IP in many ways. So we're just waiting for that really to clear itself out, but we may come back to that in a moment to show you how that works. So now I've got that actually working. What I actually need to be able to do, and now this VPN will be fine, I can actually ping from this remote end. Like I said, I can ping a number of the devices on here. Maybe this is your NAS server, a different file server or something like that. So we've actually got quite a lot of that functioning as it needs to be, and that might be all that you need to do. In my instance, I want to push it a little bit further. That IP address, the .1 here, is actually a router on my local network, and it handles a whole load of traffic out to a whole lot of different sites. Now, the problem is that if I was actually to try, so let me show you how this works. So I've got a DNS server that you saw in one of the other videos here on this IP address. So currently, as we know, this IP address is not in the LAN segment of my EFG. So if I actually do this, I can see, all right, that it goes from my remote end, so where I am, so my Windows machine goes to the LAN interface of my UCG. From my UCG, it goes up the WireGuard VPN we've created and gets the EFG. The EFG says this is not in my local network, and therefore passes it out of its WAN interface, its internet facing IP address, and routes it out that way. I actually need this packet to actually be handled internally and trace through my internal router. So what I'm going to do in a moment is I'm going to set up another static route to force that to happen over the VPN. Let's just check and see whether this is updated. Now you can see it took a few moments for probably the ARP cache, something like that, to clear, and now I can ping here. So let's just close this, clear this screen. So what I want to do is be able to set up a static route that directs this other network of traffic. So if we actually have a look onto here, and we're going to go to static routes. You could potentially do this in policy-based routes if you want to, but I like static routes. So I've got this IP range here, and I like to do this just to remind myself when I find them what it is. So I've got that range because I had .40 in it. Our distance, we want to be nice and close as possible. And essentially I'm going to define that same network as where I'm going. And then I tell it where does that router live. So in this instance, it lives on my LAN interface. That's in the subnet of the LAN side of my EFG, which is the key. But obviously this IP range isn't. So I'm now going to add my static route entry. And let's hop on back to our computer here. So let's trace 10.0.0.0.40, and let's just see where that hops to. So you can now actually see that that has hopped from our UCG to our above WireGuard VPN, and before, if you saw that, that had gone to a WAN IP address, my 172 IP address, and this is actually now passed to my internal router, and so now my traffic is going out that way. It's going to the LAN, to the internal router, and will find its way around my internal MPLS network. So I've actually been able to now set up a static route to redirect that traffic again. So if we were to push this idea or this theme a little bit further and maybe come back to routing on here, where we have our policy-based route at the moment, we had a route that said all traffic. So now how about I change this? And it's not maybe as nice here if you've got lots of IP ranges, but let me just show you what you could do in here if you wanted to. We're going to have 1.254. Maybe I've actually already, oh yeah, okay. So that's probably going to cross over, so I can remove this one here. So I've now chosen, I only want to send up the VPN tunnel. This is my UCG end. I only want to send up the VPN tunnel. Anything, I think I've actually got this one the wrong way around. So I want to send anything from that range all the way up to the end of the next one up, 1.254. So as long as it's destined for that, then I want it to go up the VPN tunnel. So let's just have a little look here at the moment. So originally, if you remember in this window here when we did a trace, our trace went out the VPN, and which it still is. So let's just give that a moment, maybe for the for this to update itself, and we can actually see there that this went straight out my 4G connection. You can see we've changed the route again. So actually, my internet connection is going straight out of this unit. It's no longer going over the VPN. But if we do a trace on this side to the same IP address that we had, we can still see that it is actually going the same way. So we've now created a split VPN instead of a tunnel all. And the advantage obviously is this, is if you only ever need to send your internal traffic and you maybe just don't need to push all of your web browsing and download traffic through a central hub, because essentially we're creating a hub and spoke VPN here, then you can create a split tunnel a VPN by building it up like this. And if you had multiple ranges like I do at the other end, then you could actually set this up this way around and add in multiple ranges to actually make that work. So where we are at this point, we've done split tunneling. I've shown you how to add extra routes in here to actually set the traffic that where you want it to live. If I wanted to add another subnet in here, then I could add another subnet in here in the same way, and I can have multiple subnets. This is at the EFG end, so once it comes out of the VPN tunnel. Now in the scenario we've got here, I'd obviously need to keep corresponding ones down here to actually make it work. In this instance, I'm just going to switch this back to all traffic, so that actually everything is running in that way, and we know that it actually works. We have had people ask about the speeds of this. There is another video showing you WireGuard speeds. You should be able to get somewhere around about 1 gig a second using WireGuard in this type of scenario from the tests that we've done. So do have a look at that on your on our YouTube channel if you're trying to get an idea of the speed. So I now want to just cover one more thing in this. I thought I'd just be able to put all of this together just to at least be able to show you as much of it as we can. So I want to just touch a little bit about the security side of things. So let's come back to our Windows PC here, and I want to just get a couple of pings going. So let's ping 10.0.1.10 on a minus T on a repeating. And over here we're going to ping 10.0.1.1 minus T. So we've got 2 pings running, and I want to show you what we're going to do. So a VPN is great, but essentially as a default in our EFG we have a we can get to any rule anywhere. So I'm just going to just remove these couple of rules that I had in here, and we'll recreate these in a moment. So we've got a rule in here that essentially says allow all WireGuard VPNs. So they can get to the gateway, the device itself, and they can essentially get out to the internet and do everything else. We may want to be a little bit more restrictive, because that means that somebody who gets to my UCG end, my remote end, actually has access to all of the IPs in my main network at my hub site. So how do we drive a policy that controls what's going on? So let's just go back here with both of our pings are happening. So I'm going to add in simply a block rule. So the first thing I like to do is add in a let's block everything. And then, because these are auto-generated rules, I want to create a block rule to start with, and then I can add an allow rule on top of it. So it's super simple. We're going to choose create here policy. Where do I want it to come from? VPNs, because we can see up here my site VPNs, which all my WireGuard ones are already in there. So I want to say any IP address essentially is coming from any port. I want to block it if it's going to internal. I'm happy for it to go out to the internet, but I want to block it if we are going internally. So just need to make a couple of changes so that I can actually get, let's grab this window a minute, move it over, because the apply button or the add policy button is just underneath there. So let me just make sure I've chosen internal, and you can see here I've got all my settings. I want it to block to anything, and you've got some quite good other options in here. So let's just put that in place. Block all VPN traffic. So I've added in my block all VPN rule, and we can see that that's added in here. If we go back here, we can see both of these have timed out. If I do a ping 8.8.8.8, we should still be able to ping the internet. So we know that this is actually functioning. So now we want to be able to develop this a little bit further and go, well, okay, I would like it to be able to access .1, but not .20. So we've created our block rule. We're now going to come in and we're going to create, let me just move this over so I can get at the button when we can do this. We're going to create an allow rule. So I'm going to choose, where does this come from? So I'm going to choose allow access to 10.0.1.1. Now you could create subnets instead of single IP addresses. I'm going to choose from the VPN. I want to choose allow. My destination is internal. And I'm just going to allow a single IP. You can define objects in here, which is quite cool. But in this instance, I'm just going to put this in 10.0.1.1 and add that rule. And I'm just going to now add it, and it's applied, and you can see it here. So let's just hop on back over here, and we're just going to give this a minute, and we'll see what it does, or whether it actually changes anything. So I've given this a moment, probably about 30 to 40 seconds. It's not actually changed anything, and this always caught me out when I started doing this, because I was like, but I've created a logically correct firewall rule. I've got an allow. This says allow. I had, first few times I did it, I forgot to change this to be allow. And I'm like, and it seems to be above it in the list. And it wasn't until I did a little bit of working around, and let's just go back here and just check that yep, it hasn't made any difference here. What I actually realized was that you need to have the right policies ordered, but the order that we show in this list is not necessarily the order in which they are actually inside the category. So what you can do, where you can see this VPN here, we can choose view policy, and now this is the current order that you're in. And so actually you can see I've got an allow right at the bottom, I've got a block right at the top, and I've got an allow in the middle. So the firewall rules are processing from the top downwards. So that's where really this is a bit deceiving, because this isn't actually giving you any order. And I wasted quite a bit of time when I was learning this. I'm going, I can't understand what I'm missing. And then I realized you have to create the order per zone that you're in. So once you've found the zone that you're working on, mine's VPN, we can choose manage or we can choose reorder. And now we can literally move these from one to the other and choose done. And if we just flick back to our device over here and just give it a moment, it takes, like I said, normally about 30 seconds. It seems to be somewhere around about 30 seconds for the firewall rules to update. You can see now our ping has actually come into effect. So I hope that gives you a bit of help. That was a bit of a gotcha for me in the fact that I was concentrating on the all policy and the order that they were in here. Even though this is now changed to be the right order, it didn't seem to have any logical listing, and you can't choose the reorder from this main menu. I don't think you can from here. No, you can't. So the only way you can do it, you can only reorder with inside the zone, and the zone is a group of interfaces. So once you've gone into that, you can then reorder them, and that's how then essentially the firewall rules come into effect. So I hope that that's been useful. We've run through the creation of the VPN. We've run through the configuration of creating a VPN server, because remember I couldn't do a site-to-site because the remote end didn't have a static IP. It needs to have two ends to be able to talk to each other. We exported the file out of this. We put that into the UCG's config over here in the client section and got the connection up and running. We then needed to create a policy-based route to forward the traffic up to that hub, because we're now a spoke. And then on this end here, we enforced we needed some routing. We needed some routing and some NAT. So in our instance, we needed to create a source NAT that translated all traffic that came out of the LAN interface to the LAN IP so that routing could happen. But that may not be necessary for you in your setup. We added in some static routes to show that you can add in routing for any subnet you want, as long as there's something on your LAN subnet you could route the traffic to. And then in security, I just showed you how to create some basic firewall rules here, and you could do that for other zones and types if you wanted to, but this was for our VPN to internal, and just showed you again that you needed to go into the policy section to be able to reorder them for that to take effect. So hopefully that's useful. Head on over to our YouTube channel. Hopefully there's plenty, you'll find plenty more gold over there in many of our how-to guides, box openings, performance tests, all of those type of things. So why don't you subscribe and stay up to date.